I recently learned about this Nigerian from Africa who apparently found a way to do banking on a mobile app without any internet. And I found that particularly interesting given that today is October 20, 2025, and Amazon Web Services has been down for the count for a good bit. The DNS servers for Amazon had some issues. They were either misconfigured or had some other issue. That's the official story, that the DNS servers went down. And with it, many apps and many software applications and many organizations that made their transition to the cloud found that their software application systems, infrastructures, you name it, just wasn't working. People couldn't book flights. People couldn't conduct transactions. People couldn't do a whole host of things because Amazon was the single point of failure. It was the bottleneck. So, the thing of it is this Nigerian developed a way to do banking even when the internet's down. And I saw that story and I was like, that sounds pretty cool. But the thing about that story was he presented his idea to investors, to an investor. And this investor only talked to him about, 5 minutes? And then ended the call. And then later on said, oh, that idea would never scale. That idea would never scale. It would never go to a lot of people. That investor, it turns out, either was that investor or someone else, they invested in a Silicon Valley startup instead that made an app that told you when you were thirsty. I think they got $6 million investment for that app. $6 million for an app to tell you that you're when you're thirsty, or to remind you to drink water. So that water app didn't last 6 months before it went out of business. Whereas the Nigerian in Africa has an app that can potentially reach over 1 billion people. So you have software developers and entrepreneurs in Africa building apps for what people actually need, instead of apps that deal with people who are already comfortable. So it reminds me of the same discussion about artificial intelligence. I talk about AI as much as I do because there are people that I know who are trying to get ahead in this world, myself included. And if you listen to the wrong people, you will lose your blessing. You will lose your opportunity. And there are people trying to learn software development today. They're trying to learn how to build apps. They are learning how to get their careers off the ground with software development and with technology in general. And there is a chorus of people out there that say, you shouldn't touch AI. Now, I don't think they put it exactly in those terms, but that's the impression that you would end up getting. That's the impression you would get. You would get the impression that this AI is a horrible thing and it will make me dumb. It will keep me from developing the skills that I need to develop in order to be effective in the future. So that if I totally ignore AI, then a year or 2 or 4 from now, when the whole AI bubble crashes, then I'm going to be the last person standing, and I'm going to have the skills that the people who invested in AI don't have. That's one of the narratives that's out there. So the thing of it is that the dot-com era happened in the late 90s, early 2000s. And you had many companies crash. You had a dot-com crash. The dot-coms is when I started my career. So you had all of these major internet companies with abundant marketing hype. They were hyped up. They knew how to get money from investors. And what they ended up doing was going out of business. Many people lost their jobs. It was a horrible situation. So the thing about that is, although you had a dot-com crash, here we are 25 years later, and you still have dot-coms. You got Google.com, Amazon.com, Microsoft.com. Well, Microsoft was not a .com, but you have all kinds of companies that survived from that time and still persist today. So when a bubble pops, that doesn't mean the whole thing goes away. That just means you have survivors who are going to be the new standard from that point on. So that means that some of the AI companies are not going to survive, but that doesn't mean that AI doesn't survive. AI is here to stay in the way that we call it AI. So I see videos all the time about, AI sucks. I see videos all the time about AI sucks. And what I think about that is, I used to say the same thing. I have videos where if you read between the lines, that's pretty much what I said in 2023. In 2023, and maybe at the beginning of 2024, I was pretty much saying the same thing. I have since changed my view. And what I see with all of this is that, or what I like to say is, there's a joke in the software development realm. It goes by the line of, you're holding it wrong. Right? It says you're holding it wrong. And what is meant by that is that you may have a complaint about a tool or a programming language, but really it's a skill issue. You don't have the right skills. You don't have the right understanding, and that's why you cannot execute it. That's why you're complaining, because you don't understand. So that's what we're seeing with AI today, is that many who complain about it, they don't understand. And that's a hard thing to say, and it's a hard thing to accept, because those that learn how to write computer programs and write complex computer programs are very smart people, highly intelligent. It takes a certain level of intelligence to be able to work with computers and control them through software program languages, and do it in such a way where the more complex that program is and the more reliable it is, the more it is a high praise of your abilities as an individual, intellectually, and in many cases intuitively. And so it's the classic issue that high IQ in one area doesn't always transfer into other areas. Just because you're a rocket scientist doesn't mean you're going to know how to change oil in a car. So what I have seen with the discussion around AI sucks is that it's like when Grace Hopper created the compiler. So Grace Hopper was this Navy admiral. Grace Hopper, she was this Navy admiral, and she invented a way to do programming where you write program instructions in relatively human language. Sounds familiar? And then she had a tool that would translate those human language instructions into computer instructions, because computers don't understand human words. They understand 0 and 1 as electrical voltages. That's how they operate. And Admiral Hopper bridged the divide, where before her invention, computers were programmed in a very pure mathematical way. That's still a great misunderstanding, even nearly 70 years later. The general public thinks that programmers use math to program computers, and programmers don't. Programmers today don't do that. They use a English-like language, but it's a very strict language. So C++, C#, Java, TypeScript, Python, Go, many of those languages, all of those languages, they have English words, and those English words have to be strewn together in a very specific way to get the computer to do what you as a programmer instructs it to do. And people invest a lot of time. They read lots of books. They read lots of articles. And these days they watch a lot of videos. And after all of that time investment of either going to college or going to a boot camp or teaching yourself, after all of that time, which can span years, you reach a level where you can build production grade, very reliable, high performance software applications with your own hands, with your own mind. And you can do it step by step and piece it together. Except that the final computer program was not built by your hands. It was actually built by the compiler. It was built by the translation tool, because you didn't write the ones and zeros. The compiler did. And the compiler does not write the code the way that you wrote it in English language, or in that restricted English language we call a programming language. Your programming instructions get translated. One line of code can get blasted out into 10 or 100 lines of code, depending on the compiler. And so the final computer code isn't code that you wrote. That's what the AI, or what we call, that's what it is. It is just another layer of translation. You talk to it either through the keyboard or verbally or whatever, and it's going to then take your more broad and ambiguous human language, English language, and it's going to compile it to programming language that then has to be compiled into the actual computer program code. So it's an additional layer in the whole tradition of adding layers in the computer world, because that's what's happened over the last, I'd say 30 or 40 years, is this parade of abstractions, this parade of layers. That's how programs are built. They're built with these layers, these abstractions, these tools. No one actually just writes a code and it goes right in the computer and does what it does. There's layers upon layers to get it to the final point. So, I've been writing code off and on since the 1990s. I started with GW Basic. In actual MS-DOS, I wasn't on Windows, it was just MS-DOS. It was the true MS-DOS. It was true command line all the way through. And I spent 13 years with C and C++ in Linux, writing a variety of apps for me personally. They're production grade. It's all great stuff. I spent 20 years in software development roles for companies as a Microsoft.NET C# developer. I am one of the original .NET developers since it was in beta, and I still write .NET today. So going on 25 years of .NET. It's been great. I like what's going on with .NET, and like many of us, you could say my origins was more hacker oriented, right? There's these labels that come up in the programming world. You're a hacker or you're a professional. Hacker usually gets used as a term of derision. It's usually a way of not so much insulting someone, but diminishing the quality of what they're doing when it comes to code. What I mean by that is you have individuals in IT or in IT quasi-IT roles or whatever, or software developers with a certain mindset, and they're all about professionalism. And if you're the type that is more on the side of, I'm just going to get it done no matter what it takes, and maybe you're not all in on documentation and comments and continuous integration and continuous development, and you're not going to try to find all the rigorous pieces of information to support what you're trying to implement, and you're just like, I'm just going to code this, and we're going to evolve this thing and get it done and call it a day. They'll call you a hacker because you're not following processes in a rigorous, structured way as part of your DNA. So I know that for some this might come as a surprise, but no less than 20 years ago and earlier, the majority of software developers did not believe in writing documentation, did not believe in commenting their code, did not believe in tests the way that it's done today, did not believe in the whole structure that we have today. The majority of software developers did not believe in that. And they had their reasons for that. I was too young to know the difference. So I just came up in that culture and it was cool. But as I matured in my career, I basically embraced the growing professionalism. And so I evolved into more or less a professional software developer. But because I have those hacker experiences from the early years, I can change gear, I can shift gear. I can drop all the professionalism, and in some cases professional pretense, and just go, let's go, and just drive and just make it happen, right? And that's fun when you're young. But I've written well over 500,000 lines of code. I at least remember the 500 million lines of code, and I've written a lot more code since then. So I won't say that it's approaching 1 million. It's probably more like 700,000. But after you've written that much code, you're like, I no longer have anything to prove to myself. I really want to build this program really well, and let's do it in the most streamlined way possible. So that's where AI comes in, where you're able to do that. Now, here are some things that people who say AI suck come up with. They're like, they love that dopamine hit. They love that dopamine hit from solving hard problems themselves with their hands. They love toiling through the code. And I'm right there with them. I see artistry in code. I see the engineering side, but I also see the artistry side. The thing about it is, though, is that artistry doesn't apply all the time, just like engineering does not apply all the time. There's a time and a place for enjoyment, and there's a time and a place for having the right structured processes in place. And I think too often we get far less practice, experience, and exposure to structure, to the point where we don't have the structure when we need it. Earlier in my career, when I was doing software development for companies, the senior people would criticize the young version of me and be like, hey, don't start coding yet. We need to design this. We need to plan this out. And I went against my instincts, So I was like, okay, sure. And so you just work through it. And eventually I learned how to do detailed requirements documents, 100-page, 200-page requirements documents, following the whole structure of how you do business analysis and traceable requirements, and how that then translates into specifications and all that good stuff. So then when AI came along, and I was like, you know what? It's like, man, my instinct was, man, this thing can just generate some code. Let me just lay this down as a prompt, and it's just going to come out. And that was that hacker instinct. See, some of my personal projects, I can plan them out in a very structured way, and I get in there and I got blueprints and diagrams, and I'm working for like a month, 2 months, laying it out before I even do some coding. And then other things that I code, I was like, I only need this for like a short period of time, some like, short-term utility. Let me just code this up. I don't need to plan this out. It's just going to be a .NET console application. I'm just going to blurt out the code that I've done 100 times. System.io, .file, open. Let's just get some stuff done. Let's write all text, blah, blah, blah. You're done. Okay. But the thing of it is that some of those temporary utilities sometimes become permanent, and then they need to grow and they need to evolve. and they would have benefited from some design up front. And some of the things that you intentionally design can benefit from having better design so that the quality is better, the end result is better. So that's what the AIs actually bring out. They're bringing about a style, if you can say style, or an approach to software development that benefits more from the professional way of programming and engineering than from the hacker and organic way of writing software. And you can have some very talented people on your software team that can write some really great code, but inside they really rail against professionalism and professional standards, and some find it soul crushing. I'm flexible either way because I'm not defined by my job and my job requirements. You do what the employer is asking you to do, and you do it well. But some people, they rebel against that, and they have a more difficult time. The AI that we have right now, it works really well when you can lay out your software application as a blueprint, when you can actually blueprint it out. GitHub and others have some good ideas about how you do that. They have this thing called Spec Kit, SPEC, Spec Kit, like specifications. And that's something that I'm researching right now. I'm learning all about that. I'm actually having fun with this stuff because it's like, many of the programs that I try to build, they are programs that all the design is in my head. The blueprint is all in my head. And I have not always had the incentive to write it down on paper. So I'll go an entire year building a software program. The blueprints are all in my head. Some of it I've written down just to have anchors to navigate and stay on track. But AI brings a lot more of that out. And it's a good thing because it allows you to check the quality of your thinking up front. It allows you to already be in a position for the eventual documentation. It allows you to actually come face to face with what you're trying to do, to come face to face and look yourself in the mirror and be like, okay, I really am missing this vital piece of this entire design and did not realize it. And so it actually saves you time in the beginning. It seems like you're spending a lot of time with the prompts and with the discussions, but the more you persist with it, it's just like advanced software development. You get faster the more experience you get, and the more capable you are. You actually become faster. And so the brick wall that people ran up against with AI, some of that, if not much of that, is just that impatience, that desire to just hurry up. And that's not what you need when you're trying to build quality. So here are some things that you need to know if you're going to be good at this beyond what I just laid out. AI is not going to replace software developers. That was a narrative that was put out last year and the year before. That turned out to be false. That's actually not true. Now, some of the executives thought it was going to be true. It did not work out. And it's not going to work out like that. You got a couple of problems. Number one, you are not going to get those data centers that they're talking about. You're going to get some, but you're not going to get all those data centers that they're talking about for AI. You're not going to get them. It is too expensive. So part of the AI bubble crash is this, that what they are asking for as an industry costs too much. Now, people are saying that they are offering money, but the money is not real. It's just like 2008, the Great Recession, when the recession crash came. It's just like that. Just like it. We got this concept right now called circular money. Some people are getting money from one group, right? Some people are getting money from one group, and then they're passing that money on to another group, who is passing it on to another group, and the money is like, it's the same money just moving around. So nobody actually has the money that they say they do for the AI. The other problem is that the companies that make the AI, they actually don't know how to make money with the AI. They don't know how to make money with the AI, and that's cool. Hey, that's not your problem. Just use it. Use it to get ahead as far as you can before it falls apart. Use it to get ahead as far as you can before it falls apart. It's just like a content creator, which I'm not. It's just like a content creator during the year 2020, where everybody was, at home, and some of these content creators had like a captive audience. And then what ended up happening is some of these content creators made like a $10,000 a month. Some made like $1 million a year, and they got rich off of content creation. But then 5 years later, they couldn't make that money anymore, right? We're in that period right now where some of these content creators that got rich during the 2020 time frame and, past that a bit, they're not making that kind of money anymore. But they made their money. You see what I'm saying? They made their money. And now they can use that money that they made for other things. It's the same way with AI. You can make your money now if making money is your goal, or even, build what you're going to build, streamline what you're going to streamline while you can. And then if it crashes, hey, at least you got something from it that you can use for whatever comes next. So this is a great opportunity for me to actually take my software development to the next level. That's what I'm using AI for. Is I don't always get the opportunity to practice certain things in software development. I know how to code, I know how to do all that stuff. But when it comes to the management side of it, the process side of it, when it comes to the actual design, I'm an excellent designer, an exceptional designer. But doing that from mind to text editor to code, that's great. But doing that through a elongated process, that's even better, because that's scalable. That's something that can be channeled through a team at some point, and would really enhance my abilities to navigate software development opportunities. And with that said, you've got to know that the foundation still matters. The foundation is how you aim the weapon that is AI. You gotta know what you're doing. So AI does not necessarily take somebody that doesn't know software development and gets them there quicker. It doesn't necessarily do that. So you're still going to have to build programs by hand. so that you have the fundamental muscle memory. It's just like doctors today. Doctors in hospitals got all kinds of tools at their disposal, but they still got to go through medical school, and they still got to work with medical procedures with their hands to know what they're talking about, right? And it's the same way with the AI tool. So you still got to get into your data structures, your algorithms, complexity analysis. My favorite metrics is cyclometric complexity. That's what I focus on, as well as memory and performance. You got to work through concurrency, error handling, debugging. You got to still be good at all of that, right? Because that's what helps you not only set the constraints for the software design, but that also allows you to identify when the AI output is going in the totally wrong direction, and to be able to correct it. And then once the AI generates the code, as long as it gets you 90% of the way there, that's a win, because that's a lot of boilerplate code you don't have to write. That's a lot of or today's word, ceremony. They don't like to use the word, it's not but people don't use the word boilerplate, they use the word ceremony. Anyway, you end up with code with less ceremony, or at least ceremony you didn't have to put in place. So the thing about that is, when the AI produces code, you still are going to be hands-on with it. It's just that you're hands-on with it at a different level of emphasis. So that's how I use AI. Generate all this boilerplate stuff that I don't have to generate, that I don't have to hand code anymore. Because breakthrough innovations is not in coming up with the 1,000th tweak to some routine thing you've done, but in focusing on that the real core that not even AI can generate. That's where the real opportunity. That's why we did these architectures and I'm talking internal to the companies. That's why when you're a software developer in a company, you build like these frameworks, your own custom frameworks, and you have reusable components, because the theory is that you can concentrate improvements in those reusable components, and then you have an amplified effect throughout the entire software ecosystem inside the organization. But then once those frameworks and components mature, right, then those are things you don't have to revisit. You get to the point where you're doing less technical infrastructure and you're doing more novel and strategically important functionality that really advances the organization, advances the business, and even advances your software development team in terms of how you're able to deliver, right? That was the real potential benefit of architecture astronauts. But anyway, that's the food for thought, right? And so, no, I don't believe in vibe coding. Vibe coding is not the future. The whole path of software development since the late 1970s, if not before, has always been structured software development. Structured software development. That's why we got rid of the go-to. Well, we didn't get rid of it, but that's why it is greatly discouraged, to such an extent that it's almost like a grave sin, and you would be shouted out the room if you put a go-to in your code without a really good justification, right? So the software development industry as a whole has been about structured practices, structured approaches. Only if you're on the fringes of cybersecurity research would you see any relevance in pursuing what you would call hackerish courses of action or approaches, but in mainstream software development, it has been increasingly structured, increasingly boilerplate, increasingly doctrinal. So AI just enhances that. So this is kind of my point of view on the whole thing. I know that it's not widely held by people, but I am seeing a shift. I'm seeing a shift. And people are starting to embrace it more because companies are mandating it. Deloitte got rid of some people who wasn't making that shift. So, whether it's mandated or it's something you embrace, AI is useful if you use it the right way. It does require more work to use it, so I won't deny that. It requires more setup to use it properly. But so does well-structured, highly professional software development. Software development in a big company is different than software development when it's just you and your computer in your home. They're totally different. In a big company, you got servers, you got release control, you got quality assurance department, you got front-end developers, back-end developers, you got strict rules on version control, you got tagging, you got merging and branching, you got all kinds of things going on there. You got unit tests, test-driven development, you got integration testing, you got acceptance testing, you got user communities, you got A/B testing, you got documentation that is managed through documentation repositories, you got all kinds of things that in your own home-brewed software development you're not going to do. But there are things that I try to do in my own private development because they're skills. It's muscle memory. It's being constantly ready for the next opportunity. So I'm going to leave it there, and if you have anything you'd like to share, then feel free. And until I see you again, I'll see you again.